This video is on how to determine the limit of a sequence or series. These super general steps would be: first step, create the closed equation for your sequence or series, and then evaluate the closed equation as n gets close to infinity. Let's give an example. Let's say that we have this sequence right here, 8, 4, 2, 1, 1/2, etc. And you're asked to determine the limit of this sequence. First thing we're going to do is we're going to create a closed equation for this sequence. As you can see, this equation right here is a geometric sequence. This is a geometric sequence where r is equal to 1/2, etc. Okay. I'm going to use the variable k to represent which place each of these are. So let's say that this is the 0th number. This is the first number, second number, third number, fourth number, etc. And we'll call this equation or this sequence, we'll call this f of k. All right, so because this is a geometric sequence, I know that f of k will have the form of an exponential. So a times r to the k. Here, my r is that 1/2. And my value for a is just when k is equal to 0, what is this number going to be? So for this particular equation, that's an 8. So your equation for that sequence has this form: 8 times 1/2 to the k. If you want to check that you're correct, you can just plug in some of these numbers. Example, if you plug in 1, 1/2 to the 1 is 1/2. 1/2 times 8 will give you 4. All right, next step. Your next step is going to be to evaluate the closed equation as n goes towards infinity. I guess for this particular case, it'd be as k goes towards infinity. So we're looking at our equation. We're looking at the limit as k goes towards infinity. Okay? As k goes towards infinity, this portion right here let's say k was at uh, 10, it'd be this portion right here would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. As the k keeps on getting bigger, and as we keep on halving something, as we keep on times 1/2ing something, this portion right here goes towards 0. So that portion right there goes towards 0. So if you end up having 8 times 0, that 8 times something going towards 0 ends up going towards 0, because anything times 0 is 0. So as k goes towards infinity, f of k goes towards 0. Or as k goes towards infinity, your sequence goes towards 0. So if we're looking up here, these numbers slowly goes towards 0. Just a quick reminder, technically k never actually reaches infinity, because infinity is infinitely away. And so our f of k never actually reaches 0. But 0 is still considered the limit for this sequence. Pause the video, take notes whenever you're ready, continue. Okay, let's try a series. So let's say we have this series right here, and the word series means we're adding them together. So you're asked to determine the limit of this series. We're going to do the same general first step, which is creating the equation for that. I'm once again going to call this my 0th number. So 8 is my 0th number, 4 is my first number, second number, third number, fourth number, etc. Those numbers 8, 4, 2, 1, 1/2 is my f of k. Okay, so this closed equation, I already know these green numbers right here. The equation for those green numbers we just figured out, which was 8 times 1/2 to the k. That just gives the green numbers right here, 8, 4, 2, 1/2, 1, 1/2, etc. And I am adding them all together from k equals 0, and this keeps on going. So I'm just going to call this till n. So there's your closed equation, or that's an equation for the sum of the series. Let's turn this into a closed equation. Okay, so this is a geometric series. So let's use that equation for the sum of a geometric series. So I know that the sum will equal that last number in the series And when I say last number, I'm talking about my f of k's, so the last number in this series. So why don't I just put that, my last f of k multiplied by r, the ratio, minus my first number in the series, or my first f of k. All divided by r minus 1. So that's the super general formula for the sum of a geometric series. Let's actually plug in the numbers now. So here you have the sum. Okay, my last number in this series, maybe I'll just use this part right here. Sure. My last number in the series going from k equals 0 all the way to k equals n. Well, my last number is the n one. So it's 8 times 1/2 to the n power is my very last number in this series. See? Okay. So that's my last number in the series times my r. My r is at times 1/2 times 1/2 times 1/2. Show it up here. So remember, that is my r, or my ratio. Okay. So my r is 1/2 minus the first number in my series. So my first number was when k equals 0. 8 times 1/2 exponent 0. Well, exponent 0, or 1/2 to exponent 0 is just 1. 1 times 8 is 8. Or you can just look here as the first number in your series. Okay, so this is minus 8. That's my first number in the series. Divided by r minus 1. I could clean this up if I wanted to. I don't think I'm going to spend that much time cleaning it up, though. Maybe just a little bit. Okay. I'll clean it up a little bit. So you have your sum is equal to, this is 1/2 to the n power times another 1/2. This would be 8 times 1/2 to the n plus 1 minus 8. 1/2 minus 1 is negative 1/2. That's just cleaning it up a little bit. You honestly don't need to do that. Okay, next part. Step 2, now that you have your closed equation, I'm actually going to use the non-cleaned up version in case people decide to do it that way. We're going to evaluate the closed equation as n approaches infinity. So let's go. We're doing the limit as n goes towards infinity for the sum equal to 8 times 1/2 to the n power multiply 1/2 minus 8. Just copying this right now. The 1/2 minus 1. Okay, so let's evaluate that as n goes towards infinity. So as n goes towards infinity, this portion right here, if we have 1/2 times 1/2 times 1/2 times 1/2 times 1/2 over and over and over again, an infinite number of times, that portion right there is going to go towards 0. So if that portion right there, let me write the rest of this. All right, so if that portion right there is going towards 0, 8 times 0 times 1/2, this whole part goes towards 0 as well. So that whole part is going to go towards 0. And this bottom part, let's just simplify it a little bit. Actually, sure. I'll simplify it a little bit in the next step. Okay. Okay. So we've gotten this far. Pause the video, take notes, hit play when you're ready. Let's finish this off. So as n goes towards infinity, this portion went towards 0, which caused this whole portion right here to go towards 0 as well. If this portion right here went towards 0, then 0 minus 8 would be -8. This bottom part, 1/2 minus 1 is -1/2. I'm going to write this as a line instead, -8. A fraction bar just means divide. To divide a fraction is the same thing as multiplying by this fraction turned upside down, or the reciprocal. All right, so -8 times -2 divided by 1. -8 times -2 is 16. 16 divided by 1 is 16. So the limit as n goes towards infinity, the sum of that series will go towards 16.